So we have what we call group data and ungrouped data. When data is not put into classes, it's ungrouped. So you can group your data using what is called a tree diagram. So you can see from there, the smallest number there is a 0. So I want to use what is called a stem and leaf diagram. We have 1s, 2s, 3s, 4s. This is our stem and this is our leaf. So on the zeros there, we have the smallest number, which is 0, 1. So instead of 0, 2, 0, 3. So 0, 1, 0, 2, 0, 3. So the 0 is their hub. Then we go to ones. We have 13. So 1, 3, 14, 15, and 16. Then which numbers do we have next? 24,
20 series,
25, 25, 26, 27, and 28. Then we go to the 30s. We have what? 30. Then what? 32, and 32, and 34. Then we go to the 40s. We have what? 41, 42,
42,
and 43.
43.
Right. So our n there is 20. If you count all of them, they're 20. So we're going to look at parameters, starting with the range. The range is the highest number minus the smallest number. So what is the highest number there? Maximum value of x minus the minimum value of x. So we have 43 minus what? 0, 1.
0, 1.
Which is 40 what? 42.
42.
All right. Then we have the mod, is the number which is appearing the most there. Which number is appearing the most there? We have this number and that number. So this is 25 and 32. And 32. This is a 25, this is a 32, not a 5 and a 2. All right. Then we go to the median. So the quartiles, we have the following quartiles. We have what we call the lower quartile, the upper quartile, and the median. So the lower quartile is Q1. Q1. So here we're going to have what? A quarter of n plus 1. So 20 is our n. So a quarter of 20 plus 1 is 5.25. So 5.25, you round off to the nearest whole number. If it's 5.75, it becomes 6. 5.25, it's 5. But if it's 5.5, you add the fifth and the sixth number, you divide by 2. So 5.25 is as good as what? 5. So what is the fifth number? So we count 1, 2, 3, 4, 5. So this is 13. All right. The second quarter is also the median. It is a quarter, it is half of n plus 1. Our n is 20, plus 1 is 21. Half of 21 is what? 10.5. So we go to the 10th and the 11th, divide by 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this number is 25 plus 26 divided by 2, you get 25.5. That is your median or your second quartile. Then your third quartile, which is your upper quartile, is 3/4 of n plus 1. So 3/4 of 21 is what? 15.75. So we round off the nearest number, which is what? 16. So what is the 16th number? Because what we get is the position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So what number is this? What number is this? 32.
32.
All right. So the difference between the upper quartile and the lower quartile is called the interquartile range, IQR. It's also called the quartile deviation. So the upper quartile is 32, and the lower quartile is 13. So when you subtract.
Okay, just a question.
Yes, please.
On the first quartile, you said the fifth number. I'm a bit lost how we came to 13.
So the first quartile is a quarter of n plus 1. So when you have numbers
Yes.
like 5.25, 5.5,
Yes.
and 5.75. This one you round it up to the nearest number, the fifth number. This one is the fifth number plus the 60th number, you divide by 2. This one you round off the 60th number. So that is how we treat the 0.5s. So here we have a quarter of what? N plus 1. So a quarter of 20 plus 1, which is 21. A quarter of 21 is what? 5.25. So to round this one off, the nearest is the fifth number. So we're going to count on the fifth number. 1, 2, 3, 4, 5. This is supposed to be 14, not 13.
Yeah.
Okay, that's what I lost.
Thank you. That is 14. So here,
Okay, thanks.
so in subtract 32 minus 14, what are you getting? You're getting 18. 18, right? You get 18. So our quartile deviation, which is same as the quartile range, is 18, which we found as 32 minus what? Minus 14. Is that clear? All right. Then now we have what we call a box whisker diagram, which we can draw. It starts with the lower quartile, the lower value, and the highest value. So here it is the X mean, the first quartile, which is Q1, second quartile, which is the median, third quartile, which is the upper quartile, and the maximum value. All right. So here, when we go here, we found that our minimum was what? 0, 1. Maximum was what? 43. Lower quartile was 14, then 10.5, then 32. So 0, 1, 43. 10.5, and 14. Here we have 32. So this is a box Whisker diagram. We can identify what is called an outlier by the lower bound. We subtract 1.5 times IQR. And from the lower bound here, lower quartile, we subtract minus. Here we add plus 1.5 IQR. Here we subtract 1.5 IQR. The IQR calculated already as what? 32 minus 14, which is 18. So when we multiply this one by 1.5, what are you getting? The correction term. So 1.5 times 18 is 27. So here we're subtracting, we're adding 27. Here we're subtracting minus 27. That's 2 plus 27. We get 59. Somewhere here. And we subtract 14 minus 27. Is negative 13. Somewhere here. So any number that will lie outside these brackets is called an outlier. Okay. So if we have any values that will fall outside there, will be called outliers. So far we're together. Then the values we have, values of x.
Collins, just a minute. I think you lost me on the box Whisker diagram. Where is that 10.5 coming from? Is it supposed to be 10.5 or 25.5?
The second quarter here, the Q2. It was actually 25.5. We have the lower, this is 14 and 25.5 and 32. 14, and this doesn't make sense. 25.5. Not the position, but it should make sense. And 32. Thanks for that. Yeah. Means you're following. Clarified? Are we together?
Yes, we are.
So this was a position, but this is 25.5. So they will ask you, is there any outlier? No, in this case, there's no outlier. So now, after getting that, you can also now go to the measures of central tendency. We had 0, 1, 0, 2, up to what? 0, 1, 0, 2, up to 42 to 43. To 43. You can square these ones. 1 times 1, 1. 2 times 2, 4. You go up, down there. 14 times 14, 42 squared. You get 1764. And 42 squared, 43 squared, you get 18. 49. All right, then you add them up now. Summation of x and summation of x squared. Now, if you have a Casio calculator, you can easily enter the data by going to mode, then button number 2. Press mode and SD, button number 2. The mode pattern looks something like this. So it is somewhere here. You press mode, and you are going to have three options: comp, SD, regression. So you go to SD, which is button number 2. Do we all have the Casio calculator? Are we there?
We've got like sharp.
Casio, Kenko, they're in the same category. They look like this. I'll explain the sharp later on. Okay. So you enter the data. So let's start entering the data by going as follows. So the data here, we have 0, 1. So you press 0 or 1, M plus. M plus is here, at the corner here. So 0, 1, M plus, 0, 2, M plus, 0, 3, M plus. You follow the data as it is until you enter the last data set, which is 43. So 0, 1, M plus, 2, M plus, 3, M plus, 13, M plus, 14, M plus, 15, M plus, 16, M plus, 24, M plus, 25, M plus, 25, M plus, 26, M plus, 27, M plus, 28, M plus, 30, M plus, 32, M plus, 32, M plus, 34, M plus, 41, M plus, 42, M plus, and 43, M plus. Your N must show you 20. Are we there? Are you entering? Okay, I'm assuming you're not. So I'll reserve this for another class, but if you have entered that correctly, you go to mode or shift 1, to find summation of x, you press at 2, then equals, the total here will be 473. When you go to shift 1, then you go to button number 1, you're going to get the total here is 14,273. If you can't remember this, you can do them manually. So what I want you to appreciate is the formula. The mean is summation of x over n. Over here it is 473. Our n was 20. Although you can use the calculator, shift 2 and button number 1, it will give you the mean directly, which is 23.65. The variance is given by summation of x squared and the summation of x to the power 2 over n, everything over n minus 1. So here we have 14,273 minus 473 squared over n. The n is what? 20. Everything over 20 minus 1. So what you get is the variance. So variance give you 162.45. Square root it is called the standard deviation. The square root of 162.45 will give you a standard deviation of 12.746. And find what is called the coefficient of variation, the standard deviation over your mean times 100. So this would be 12.7456 divided by the mean or 23.65 times 100 will give you a percentage divided by the mean, 53.89%. 3.89% is the coefficient of variation. Then we go to the coefficient of skewness, which is 3. We have x bar minus median over the Q2 divided by the standard deviation. So 3 is part of the formula. Our mean we found already as what? 23.65. And our median was 5.5. Then our standard deviation, we are just calculating it as what? 12.7456. 4.7456. All right. So 23.65 minus 25.5 times 3 divided by 4.7456, which will give you negative 0.435. So here, skewness shows you how biased the distribution is. If you get a 0, you say it's normally distributed. If you get a positive, you say it's skewed to the right, or it's positively skewed. If you get negative, you say it's skewed to the left, or it's negatively skewed. That is how we interpret the coefficient of skewness. This is how we find the skewness. Is that clear? All right. Are there any questions so far? Are there any questions so far?
No question.
So the distribution, if you're going to look at it carefully, the distribution has this format here from the stem and leaf diagram. So we have 0 to 40. So when you tilt it upside down, it'll look like a histogram. It looks like this. All right. Here the height is 3. Here the height is 4. Here 1, 2, 3, 4, 5, 6. Here the height is 4. Here the height is 3. Okay. So this can now become group data. Okay. 0 to 9, 10 to 19. How many are they? So class. Zero to 9, 10 to 19, 20 to 29, 30 to 39, 40, 49. Have the frequency here. The cumulative frequency here. We have the midpoint here. We have the midpoint squared here. And we have the fx. We have the fx squared. So 0 to 9, the zeros in short, how many were they? We had 3 zeros, 0, 1, 0, 2, 0, 3, ones at 4. So 3, 4, 346 43. 3, 4, 6, 4, 3. 3, 4, 6, 4, 3. So 3, 4, 6, 4, 3. The total was 20. So the frequency, we have a 3 here. We have a 7. When we add this to that, 7. When we add this to that, we have 13. Add this to that, we have 17. And we have 3 to 17, we have 20. Are we clear so far? Appeal, are we together?
Yes, we are.
All right. And the midpoint is simply adding the lower bound plus the upper bound divided by 2. So 0 plus 9, 9 divided by 2, 4.5. 4.5, when you square it, 20.25. 20.25 you multiply by 3, and 4.5 you multiply by 3 to get the last two columns. So what is 4.5 times 3? Get 13.5. And 20.25 times 3, we get 60.75. So I ask, how do I get the answer here and here? Nalula and Tapua. How do I get the answer here?
As for x,
Yes.
you add the lower bound and upper bound and divide by 2.
Excellent. So 10 plus 19.5. That is what?
29.
9.5 divided by what? By 2 is 10.5. Then 10.5 when you square it, you get 110.25. Okay. How do we get the other two columns? Yes, Delphine and Rocky. How do we get the other two columns here?
Okay, from fx, we get the frequency, which is 4
Mhm.
times the midpoint, the 10.5.
Is 42. Mhm.
Yeah, yeah. And then fx squared, we square the 10.5
Mhm.
to multiply it by 4. The 4 from the frequency.
Okay.
So,
The 110.25.
oh, correct, which we already have there is that time the 110.25 times 4.
110.25 times what? 4.
Times 4.
We get what? 441. All right. Okay. So anyone behind so far? We don't need these totals here. So here, our height is simply the distance from here to here to here to there, which is 10. So yeah, easy. You can add up a what? A 10 throughout if you want. So this plus 10, 10.5.
14.5.
It's supposed to be 14.5, right?
Yes.
Yeah. Supposed to be 14.5. So just add a 10 here, which is 14.5. We added 10 here to be 24.5. We added 10 here to be what? 34.1.
4.5.
Added 10. So you're adding the height here to 44.1. 5. Then you square it 14.5 squared, we get 10.25. Then you multiply the 14.5 times 4, which is 58, and 210.25 times 4, we get 841. All right. So you continue this until you get the totals for the last two. The total you get here is the summation of f. The total you get here is summation of fx. So you can go screenshot that. I want you as a homework to simply find the summation of what? Summation of fx, summation of fx squared. So you find the what? The mean, which is summation of fx over summation of ef. This is our ef here. Then you find the variance, which is summation of fx squared minus summation of efx squared divided by summation of f, everything over summation of f minus 1. And then you square root it, you get the what? The standard deviation. You also find the coefficient of what? Variation, which is summation of f, the same formula we found at first, over mean times 100. So this is how we compute group data. So I will, as part of your homework, ask you to find the mean, the mode, and the median. Please find out. If you get stuck, this is homework. You can consult from your spouses, your husband, or your wife. All right. I need us to move steadily. End my session here.